Good afternoon, everybody, and welcome back to this year's Open RAN Summit. My name is Oliver Ward, your host for the show. Please allow me to start this session by thanking our partners for supporting this year's event and to make sure you're checking out the Partner Content Hub for any content that has been provided by our partners. Make sure you're joining the discussion online with hashtag OpenRAN and that any questions you have for the speakers during the session are going to the Q&A tab at the top of your screen. We've had some great content so far, and so that you can best prepare for what's next, here's what to expect. Getting us started, Ravi Sinha from Reliance Jio will deliver the opening keynote. Then we'll have our partner keynote from Mavenir. After, Viet Nguyen from 5G Americas will moderate the panel as he is joined by speakers from Rakuten Symphony, Intel, and Open Infrastructure Foundation. And then we'll have a closing keynote from Wind River. So that's enough from me for now. Please allow me to welcome Ravi.
Hi, everyone. Greetings from Reliance Jio as well as ORAN Alliance. As some of you may know that I also co-chair ORAN Alliance's 6G initiative called NGRG, Next Generation Research Group. So I would like to present mainly the aspects and some of the updates from 6G initiatives within within ORAN Alliance, and then I'll go to the next topic, which will be kind of how the next generation of edge infra, which is a very relevant part of your cloud native asset, is moving. So let's start. Since I have to cover close to 15 slides, so I will not take a lot of time. I'll move fast. So at the end of the time, if you'll have opportunity, we can take some questions as well. So this is who I am, and let's start. So NGRG, as you can see that we started this initiative a year back last year. And I'm very proud to say that this whole initiative is taking shape in a very good way. It is important to show you the fabric, what exactly is the flow, how exactly we are moving, and what is our achievement. So I will go with the basic motto over there. And we can say that it is just to provide a forum, facilitate ORAN related 6G research efforts and publish research findings. So we are mainly differentiating with the rest of the work groups that we are mainly focused to the research groups, and we always leverage the capacity of the industry to move forward with all what is going to come in the next set of 7 years, 2030. So that is the goal. And what exactly we are going to achieve is ORAN sustainability from 4G and 5G to 6G and beyond. As far as the operation is concerned, the major areas will be define the ORAN NG the research agendas and move forward with the outcome of it, establish the research streams. And at present, when I'll go to the next slide, you can see that at present we have 5 different research streams. So, but mainly we have divided our approach or goal to 3 parts. So one will be going up to 2025, and from 2025 to 2027 is the midterm, and then a long term is 2027 onwards, which will be a POC and deployment level. So what exactly is the near-term goal to 2020 to 2022 to 2025 is meant to align with the industry and figuring it out what will be the broader scope of our work and what are the areas we can play with. And of course, from 2025 to 2027 will be based on the research findings and how we can align our work groups as per that, and how we can better align with the rest of the standardization committees in the world, including 3GPP, IEEE, TIFG, NSF, and all. So that will be the major focus. If I go to the structure of it, as you can see that the set of 12 members of the NGRG Technical Oversight Committee, including the major operators of the world as well as the vendors of the world, including AT&T, CMCC, CTC, T-Mobile, Jio, Nokia, and all. And if you can see the research streams, and we all are under the executive committee of Oran Alliance. There are 5 different research streams, including the use cases, architecture, native security, as well as the next generation infrastructure. And it is good that we have provided next generation infra, just to make sure that we can promote all what is going to come in the coming 7 years, how exactly we can move forward with it. And then from the academia also, we have participants from every continent. So one participant from each continent. So this is how we'll move. You have the slides in front of you, so definitely you can take a look. I'll not go to the details of it. And then I'll go to every individual. You can see that research team 1, we are doing a lot of progress. And over here, these are the 4 different members of leadership. These are the co-chairs of the research teams. Similarly, RS02, which is the architecture part of it, there are 4 of them over there, mainly focused to every research item we take, like it will be taking care of the architectural part of it. Then you have native artificial intelligence and cross-domain artificial intelligence. This is a new area we have added. So we are very excited about it, and very soon you can see that research report is coming out of it in near future. Another one is your native security, where we are covering a lot of native security related stuff, not only limited to SASE, but all related to quantum encryption, the landscape of security, and whatnot. And then, of course, the next generation research platforms, which will be a playground or a promotional playground for all the POCs worldwide, which will be participated by academia and all. I think the most important part to cover over here is we are also this year going to sponsor a research project among academia and research organization. It's a 200,000 plus VAT and all. So this will promote our presence and footprints for 6G, and it will also give us the opportunity to collaborate with academia and research organizations. So we had a call for a proposal, and we have just closed the proposal. So now we have got a lot of response worldwide, and we are in a process to overall moving forward with like the analysis of it, and ultimately we will declare the winner or winners based on the situations, and we will come to you in a form of a press release and all, so you can see it from our executives. So this was all about NGRG and all. So all what I'm showing you over here is all about, this is what we are kind of working on every day, and we are trying to promote promote the different aspects of technology, especially 6G, in terms of different research teams. So I'll rather going to the standard architecture and how exactly it is aligned with the cloud native conduit of that. Like I will rather go to a little deeper and some of the most interesting areas which are important for all of us to consider. So these are the 6 different areas which will be a kind of which will really kind of disrupt the market, especially the next generation edge infra, which is nothing but the next generation of cloud native framework. So one is your AL platforms, which is kind of giving you the acceleration as a service, and this is very important. The second piece is your CGRA and FGRA. These are the coarse-grained reconfigurable architecture, and FGRA is the fine-grained reconfigurable architecture. The way hardware requirements are moving that fast and on fly, I think we need, and I'm seeing worldwide also, there is a lot of take on how you can on fly you can change the architecture of your, or the behavior of your hardware domains and platforms, and moving forward to that. Metaverse and digital twin is another area which is also changing, and just to support that, you need to build a platform which will be heavily supported by the next generation edge infra. And this is also one of the deterrent. Also, security-wise, quantum encryption and security is another area. Like we are going to have a release paper now, and how exactly it is going to change, how the QKD and FQC, these are the 2 different aspects of security along with SASE, how exactly it is going to change the whole paradigm of it. Use cases, the different types of use cases, as you can see, some of the ones I can tell you, UCC, RTC, and then JCS, there are multiple of them kind of also going to disrupt the whole fabric of edge infra and, of course, cloud native fabric. And highly distributed device edge, of course, but over here, we are talking about not only up to the telco edge, but we are going all up to the device edge side of it. So I will kind of rest it over there. But these are some of the areas where kind of our teams are working, as well as you'll see the research papers going on the top. So this is what you're seeing from our side. I will say that this is a kind of a standard fabric or the basic architecture of our ORAN kind of framework. But definitely, you can see the distribution of artificial intelligence, how the designers are distributed, how the different brokers are distributed. All those things will take the next steps in coming few quarters. And now, since we are talking about LLMs and all, so of course all the relevant fields which will be effective and will be a suitable case for us definitely will be working in that area as well. So now this 5G advanced and 6G features, 3GPP release 17 and beyond. So you can see that multi-TRP, whether it's FR1 and FR2, or enhanced beam control with multi-TRP, terrestrial communication going from 100 to 300 gigahertz, ultra massive MIMO communications, and ultra massive MIMO antenna elements. You can see that we are going to 2048 antennas, or 2K and 64 transmission layers, which were limited to 8 and all with 520 TRXs. So there are so many things which is going to disrupt the market, like ultra precision positioning, like a UPP, which is also equally important, to going up to 10 centimeter of accuracy. Similarly, clean energy, AI infused your control, and then visual light communication and simultaneous localization and mapping. Here also we are working heavily to figure it out if we can open a stream 3D coverage with terrestrial network and non-terrestrial network. So these are some of the areas where these are the areas of interest where 3GPP will guide the whole world. But definitely, whatever is the gap where we can play, definitely we would like to have our stand over there as well. AI infused 6G edge infrastructure. So over here also you can see that machine learning design and training, host data brokers, those kind of arrangements, and then DNN, which is also kind of a vital part for functional unit, which AL infused SDKs, which we are not kind of having it in a full way or in a dynamic way. Service driven resource management, next generation architecture for microservices, which is also taking shape with the advancements of 5G itself and moving forward with 6G. And then, of course, simultaneous localization and mapping. This is an area where we all are very interested to have the research teams which can do which can bring a lot of value over there. So these are the areas where you can see artificial intelligence will spread its wings. So this is what, over here, as you can see that now we have gone even up to the stack level as well. So rather than having just you can say the SMO, service management orchestration pieces, rather we are also going even up to the stack level and making sure that the fabric, hardware fabric, platform as a service fabric, infrastructure as a service fabric, everyone is supporting a GPU level of SDK, and then moving forward with a true, in true sense, AI enabled or AI infused architecture. And as you can see that from regional edge to metro edge to telco edge, and I'm saying that even now going up to device edge and even mobile edge, these capabilities are coming. Recently, you have seen that LLMs are running on a phone itself. So there is a lot of change coming from the fabric side. Not only going to the automation side of it or SMO side of it, but it is also going up to the stack level, up to the SDK level, and even enhanced Berkeley packet filter level, all those kind of network related, infrastructure related, and application related, going end to end. So these are a couple of things. These are some of the 4 different use cases, and then I've divided into like 6 different parts, as you can see over here. So these 6 different parts can individually assess that whether each use case, what kind of changes are needed. And as you can see that, when if we can go one by one from left to right, the changes are needed in every use case. So that means the whole edge fabric, what we have at present, may not be sufficient to move forward for 6G. And of course, you're going to see a lot of changes coming over there as well. And then the major challenges, like you can see that on device edge AI distributed device interfaces, where like people are talking about LLM or lightweight LLM, how exactly that will work. Telco and micro edge AI, metro edge AI. Over here, like a lot of work is going on, but of course, resources and data alignments and timing is the major key. Public edge AI, and then hardware requirements. So those are some of the major running factors over there. Positioning and then recognition and imaging and multiple other things related to that. Compute centric semantic communication is one where there is not a much of work has gone. Multi-point sensing, network coordination, deep infusion of information for next G services, cell-free massive MIMO, which is going to be one of the major challenge and value add. Common infrastructure for TN and NTN. Here also, I'm not seeing a lot of coordinated work has gone. So similar to that, highly distributed architecture, as we talked about FGRA, CGRA, and all, which will also add a lot of distributed architecture support on fly, native security, and all. So all these things are also going to add a lot of value, but going to disrupt the whole fabric of edge infrastructure. Edge platform with the AL architecture, highly distributed DNN and CNN functional unit. These are the convolutional neural network or deep neural network kind of framework. Exactly how it will fit in the coarse grain reconfigurability, as we talked about, the single fabric should handle all computations. Doesn't matter what kind of use cases you're choosing based on the slices, performance, massive parallel processing, and the megaflops of operations, software controlled hardware, billion parallel threads, high reliability and availability and adaptability, major accelerator types, leukocytes, and then inline accelerators has a better future, of course, and you can see more and more coming in that area. I'll not go to the details of the edge assisted ray tracing, but this is one of the most challenging, but one of the most value added use cases. I have seen a lot of POCs coming out related to whether the location aware or accelerated, and then in some of the massive MIMO radio channel modeling and all those areas as well. So along with that, now just talk about the next generation edge infrastructure sustainability. So hardware sustainability is a major. The teams are working on multiple aspects of that, whether it's a hardware driven energy efficient radio and telco servers, and then the multi-phase immersion cooling for the edge infrastructure, especially for the hardware, software like AI/ML infused, energy efficient and power efficient. And a lot of work is also going over there just to make it a true cloud native. And then open API and standards. This is the area where a lot of work is done, but I feel that a lot is needed. And then, so you can see the quantum security side also, great risk, but a great reward coming out of that, and the major challenges and asks coming out of it. But I can only say that QKD and FQC, these are the 2 areas where whether it is satellite distributed or locally generated, both ways, whether it is being distributed on optical fiber or a standard public network, those are some of the challenges, especially at the era of quantum compute. But you will see like multiple algorithms and approaches coming from NIST is going to kind of relieve a lot of pressure over there. And especially the silicon fabric, also I'm seeing AI driven, but very specifically customized for ransomware or the quantum attacks, can also take care of it. So I'm seeing whether it is cloud native, but when the fabric is changing, the solutions are also coming along. This is last but not the least, but definitely we can see that the edge infra SMO and rig framework, the way it is moving, where we are not only kind of limited to SMO, but end-to-end SMO as well, or you can say multi-point SMO, or multi SMO at a single platform as well, where at least you can see that the multi-domain SMOs, as well as some of the core functionalities like NSS, MF, and then IWDAF and a couple of other things are coming to these platforms to coordinate the different slices, different types of slice. And overall, I'm very hopeful that the kind of work our teams are doing within ORAN Alliance will be a great value add. And within a couple of weeks, you can see some announcements related to the funding we are going to do. So I'm keeping my fingers crossed, but have a high hope, and probably it can add a lot of value to the industry. Thank you very much. I think I'm done from my side, and hope I was on time. Thank you.
Thank you so much, Ravi. Up next, we have our partner keynote from Mavenir. Handing it over to you, Pardeep.
Hello, everybody. Thanks for the opportunity. Open RAN is a big topic. It's basically people, view it from many different perspectives. And the biggest perspective, of course, is right. How is it going to overall bring innovation and also bring the overall cost of deploying the networks and as well as running the networks down? I mean, the cost of running the network, bring it down. So what today I'm going to talk about is Open RAN also a way to migrate the network to become more cloud native? And one of the things I think people talk about, overall the cloud native solutions, it's not only just the telco industry. Other industries are going through this transformation as well. And the whole idea of having a cloud native solution is that cloud adoption of cloud actually makes things easier to deploy and operate. So the key tenets are how do you bring more agility, because typically the proprietary solutions have customized tools and they are designed by each vendor differently, and each vendor takes its own way of doing certain things, and you have to learn about it. And then there's not much of reuse across one vendor to another, or from one vendor or from one industry to another. So one of the things which is happening is, right, that when people adopt public cloud or private cloud, whether you adopt Kubernetes or you adopt the AWS tools or Azure or Google, you are actually using the same tools across many different industries. And what that means is, whether it's a banking application or whether it's a logistics application or whether it's a telco application, the way the application is onboarded, the way it is brought up, the way it is managed, where you run through the whole life cycle, is largely using a common set of tools which are tested and validated across many different industries. So the whole idea of the cloud native solution is that you enable agility, you automate the different aspects of deploying as well as running the network, and that itself, by simplifying it, brings in more innovation. Because if it takes less effort to bring new features in, and changing the network, or bringing new capabilities in the networks and making it easier, that means people will do it more often. And what that really means is that overall you're able to innovate better, adapt to the circumstances, and adapt to what the environment around you requires and what the devices requires, and make it easier and bring the overall innovation in there. And overall, result bring up the whole CAPEX OPEX down, because by ability to make changes faster, which means that you can always adapt to the latest technologies faster, and the latest technologies can help you bring the overall cost down. So that's what Mavenir is focused on. We have now many deployments where we have deployed open architecture, where customers, like I use Dish as an example, so they only buy software and services from us. Our software runs, certain aspects run on AWS, certain aspects run on VMware on a Dell hardware, and we interoperate with, radios which are coming from another vendor, Fujitsu. So with that, there's a way to actually bring in innovation that now if Fujitsu brings up a new radio, it's not our development, it's their R&D. They invested the money to build it, but we get the benefit of it because if the radio performs better, when by working with overall the system gets better, right? Same thing, when VMware comes with certain, benefits and acceleration or improves the performance, we get benefit out of that one as well as the whole system. And of course, our own innovation, what we bring innovation to, bring the whole cost savings to for the whole system. So from that perspective, I think I would point out the key use cases. Number of times people ask me, okay, why the Open RAN deployment is not going as fast, right? So one of the things we are dealing with is that today the way the networks are being run, in fact, even with the legacy vendors, in each location we have, in each geography, for example, I'm in US in state of Texas. Each operator largely, gives a whole region and sometimes the whole state. So it's not just, city of Dallas or city of Austin. Sometimes, the whole state of Texas goes to one vendor, right? So you could have, one vendor for state of Texas, another vendor for, in Oklahoma, a different vendor somewhere else, or it's just that whole location goes to one vendor. And anything you do in that location, for example, if you need more capacity in downtown Dallas, you have to go to the same vendor which is also serving the areas around Dallas. And because that's how the networks are set up today. And one of the constraints for all of this is the operational tools and the management tools are very rigid and they are very proprietary. So it becomes difficult. So if you try to do mix and match, right, it makes it difficult to manage it and optimize it and see the where the issues are coming from, and if there are issues, how do you debug it and find the issues and resolve the issues. So in order to avoid all those issues, what operators are doing is they're taking and making sure that the whole region belongs to one vendor. And what that really means is that for us to come in and as an Open RAN vendor, I have to either go into some new areas where they have not done the deployment yet, or I have to replace an existing vendor because that's the only two options available for us to operate single-handedly in the one region. So one of the things what we are exploring is that can AI and machine learning help in overall bringing in a new vendor, whether it's us or somebody else, into a geography where somebody else is already operating. So if you need to increase capacity in a certain region and you need to swap certain sites or add certain sites to add more capability, can that be done without buying it from the existing vendor, right? So one of the things we are working on is that how do you actually bring up a new site in the middle of all the additional sites around it and use AI ML to learn how the neighboring sites are operating and adjust to it, right? And what that really means is that without requiring any coordination or any help from the neighboring vendors, right, can this new vendor come in and the new sites can adopt to whatever is happening around that site and learn. So that way, you can bring in, a new vendor or new, you don't have to worry about buying from the same existing vendor. You can mix and match a lot easily. One other example I give to the people is that, okay, self-driving cars. So if I'm a new car vendor and I want to bring in, my cars, or I want to sell, let's say in state of Texas, I want to sell, self-driving cars. None of the existing cars are self-driving. So if I have to go swap all the cars around me to, bring a self-driving car, it's going to be cost prohibitive. It won't be easy to, innovate. It will be very difficult to bring those type of opportunities in there. that's exactly what is happening in the telco industry. That to bring a new vendor, you got to swap the existing space around it, which is really not cost effective, and that becomes a barrier for new players to come in. And that's the reason the vendors are shrinking. I remember when this company started in 2005, we used to have at least 10 more companies, right? There was an Nortel, Lucent, Motorola, Siemens, in Cisco was there. So a lot of these companies, and Alcatel, a lot of these companies actually have disappeared because it's just that to gain market share, you have to inherit all of this cost to swap an existing vendor, right? So that becomes itself very prohibitive. And every year, players are spending a lot more money swapping each other than actually doing the R&D to improve the products, right? So that's where we believe that with AI ML, if we can somehow make sure that the system learns itself, so that way it's not relying on the environment around, and which what that really means is that you can bring in a new vendor, start a new site anywhere, and with that, it should be possible to bring in, new, as I said, bring up new sites to add more capacity, and improve the overall performance. You don't need to worry about how to go and change the parameters around the neighboring site, because the system itself will learn how to do it, right? And this is where we are spending a lot of effort, because typically what happens is in a performance, of course we are not on a one particular site. You have to replace the whole site, because today the carrier aggregation doesn't work across many vendors, right? Across different vendors, right? So of course, when you replace a site, bring a new vendor for a new site, you are, I guess, changing the equipment for all the bands on that site. But beyond that, how does that site interacts with the neighboring sites, and how does it learn about neighboring sites? How do you adjust the power? How do you set up the handover parameters? And how do you make sure the KPIs, which are being served previously, are continue, and the overall experience does not deteriorate. In fact, it gets better, because now it's not humans doing the optimization. It's a machine itself is learning and improving itself. So that's really the capability which we are working and bringing in. One of the things we have done in many, since we are a new player, and pretty much everywhere we go, there's already an existing vendor, and in some cases we are swapping an existing vendor. So the customer expects that when you take our solution and you deploy it in a particular location, what we do is we check the KPI and the performance with the existing vendor over a 1 week period, and then we turn the site down and we bring up our equipment up, and we compare how our system performs as compared to the way it was performing before, right? And of course, if there are a lot of issues to be resolved and they need to be done manually, it becomes very difficult to bring in a new vendor unless you're trying to do it in a new geography. But with this approach, where system itself learns and gets better, and overall the human intervention is not required, you can actually minimize the amount of effort which an operator needs to do, not only with the new vendor but also with existing vendors, in improving the overall performance. Then overall cost of maintaining, managing the network becomes easier, but also you're not tied to the one vendor for a particular geography. You can actually bring in new vendors on a need basis. Think of that's another example I give people, is that if in a house I have 25 different lamps, and if one lamp goes bad, if I have to replace every lamp around it, it becomes very expensive, right? I should be able to mix and match, and I should be able to get the full benefit without changing the whole house with all the new lamps, right? So this is where what's happening today is that just to change a few sites, add more capacity, you have to go and replace the whole geography, and which is not practical. So what we are doing is, by using the cloud native technologies with the AI ML capabilities, we are bringing in new solutions which can adapt to existing vendors and adapt to existing environment, and you can actually deploy them without requiring a lot of human and OPEX to make those changes. So thanks a lot. This is my thoughts on the Open RAN and how the cloud native technologies can change overall landscape. Thank you very much.
Thank you so much, Pardeep. Up next, we have our panel discussion. Viet, over to you.
Thank you, and welcome everybody to our panel for this wonderful conversation that we're going to have today on how Open RAN may be a conduit to cloud native. My name is Viet Nguyen, and I'm the Vice President of PR and Technology at 5G Americas. We're a trade association that is comprised of leading wireless companies, and we are focused on 5G and beyond technologies throughout the Americas region. I have today with me an esteemed set of panelists. We have Ildiko Vangsa, who's the Director of Community at Open Infrastructure Foundation, Partha Sitala, President of Cloud BU at Rakuten Symphony, and today we have Adnan Bustani, Director of RAN Infrastructure at Intel. I'm going to give them just a moment to introduce themselves and their organizations. We'll go through we'll have a nice little conversation, and then if there's some time left over, we'll do a few questions from the audience. So feel free to put in your questions in the Q&A as we move forward here. Let's start with Ildiko. Tell us a little bit about yourself and your organization.
Hi, thank you for having me. My name is Ildiko Vangsa. I work as Director of Community at the Open Infrastructure Foundation, and our organization is actually a nonprofit. We are supporting open source software development communities. Our largest community is called OpenStack. Probably most of the people in the audience heard of it already. It is a large social platform. As part of my work at the Open Infrastructure Foundation, I have obviously a large focus on community. I'm a community manager for one of our other projects. It is called Starling X, which is an open source distributed cloud platform. It is creating kind of a fusion between OpenStack and Kubernetes, and it is already running in production, powering ORAN networks. So it is very on topic for this panel. And on the technology side, I'm focusing on telecommunications, NFV, and edge computing.
Fantastic. Partha, tell us a little bit about yourself and Rakuten Symphony.
Yeah, certainly. First of all, thanks for having me here, Viet, and it's a pleasure to actually be talking about this topic today. My name is Partha Sitala. I'm the president of the Cloud Business Unit at Rakuten Symphony. I came into Rakuten almost 1.5 years ago through the acquisition of my company, Robin.io, where I was the founder and CEO. So Rakuten Symphony is the software arm of the Rakuten Group. And what we build is a series of products from Open RAN to cloud native platform to OSS products that we sell to other operators, along with deploying the same solutions within the mobile operator that Rakuten runs. It's called RMI in Japan. So we essentially build all these software tools, and that's what Rakuten Symphony does.
Fantastic, thank you. And then today, Adnan Bustani, would you just introduce yourself and your organization?
Yeah, hey folks. Yeah, so my name is Adnan Bustani. I'm at Intel. I actually joined Intel in 2014 as part of an acquisition. I used to work in a company called Mindspeed. They used to do a lot of SoCs for the wireless infrastructure side of the equation. So I have that background that came into Intel, as I said, in 2014, where the focus was to kind of really build and enable the whole kind of cloud and softwarization of the radio access network. So I'm currently in the BU called the Wireless Access Network Division. Within this BU, we actually service both the traditional RAN market and also the vRAN market. And then within this group, my focus is on three things. It is helping comm service providers basically adopt and scale vRAN. It's also working with the hyperscalers to make sure that the vRAN technology that we have is consumable by them and they're able to offer this to their customers. And then I also help with certain scale activities to help go beyond the current list of operators into a wider list of operators who are deploying vRAN into the market.
Very good. All right. Well, I'm excited to have this great conversation. As you see, we've got a great group of panelists here. What I'd like to do is, after seeing the two previous conversations that we had a really deep dive from Ravi. Initially, we had a really good sort of high level conversation that Pardeep provided us. So let's sort of set the tone here a little bit for today's talk. Talk a little bit about Open RAN and cloud native sort of separately, because sometimes they can be very complex terms. And what we want to do is maybe sort of unpack a little bit about Open RAN and then unpack a little bit about what cloud native means. So let's start with Open RAN and Ildiko. Maybe talk to us a little bit about what you sort of see as benefits of Open RAN, what it means to you and particularly for your organization.
Happy to. When it comes to Open RAN, since I work for an organization that is more on the open source side, I really like to focus on the open part of Open RAN. And I think that it is a great initiative in terms of there have been a lot of conversations about standardization and open source in terms of open source software development, as well as the standardization versus open source. And there is a lot of demand and desire to bring those two processes together, or at least much closer to each other, because it is kind of inevitable that the telecommunications space needs them both. You need standardization, you need the interfaces to be reliable and accessible. And at the same time, when it comes to open source, when you are working in an open source community, then what's happening there is consensus, common goals that the community is working towards, and they are really fast in terms of implementation and trying things out. So what you get if you bring these two closer, that kind of means that you have a really well documented set of interfaces that are also tried out, and you get a lot of user feedback. Most successful open source communities are successful because they have a thriving ecosystem. So it's not just a group of developers, but they're also having a user community who's working really closely with the developers and providing them feedback. So I think when it comes to Open RAN and looking at like ORAN Alliance, for instance, like having the standardization side and open interfaces, and at the same time having the software community within the Alliance who's also focusing on implementation and trying things out, I think that is a big benefit of Open RAN, and a good example of how Open RAN can help accelerating the telecommunications industry. And I think probably the fellow panelists will talk about other things like, the disaggregation, multiple vendors in the ecosystem, so you don't have to purchase the whole stack from one vendor anymore. You have a lot of options and choices, and that gives a lot of flexibility, and it comes with a lot of complexity. So there are a lot of things within Open RAN that I think are very advantageous and pointing towards faster innovation.
Great. Actually, Partha, your organization has done quite a lot of work with Open RAN, and so tell us a little bit about what you guys are seeing in terms of benefits and of Open RAN, and why is it significant for you?
Yeah, certainly. So first of all, we are in a very unique position that we are both a user of Open RAN as well as a supplier to the other operators with our Open RAN solution. Now, if we just kind of rewind back to when we had to make that decision almost 5 years ago when Rakuten Mobile was being launched, obviously the choice at that time was go with the traditional approach, and we took this approach of going 100% Open RAN. And I mean, if you distill all the benefits, right, it just comes down to, at a very, very high level, two important benefits, right? Number one is it drives down the total cost of ownership. And number two is that it enables a level of programmability into your network that will improve your efficiency and time to market advantage, right? Now, how does Open RAN play a role in there, right? So number one is when people talk about Open RAN in the context of vendor diversity. Obviously, you can go and pick the best of breeds from different vendors and put them all together. And the reason you can put them all together is because the promise of Open RAN is that it provides an open interface where the software components are disaggregated and at the same time they are made interoperable because of the standards through which these software components are essentially designed, right? But there's an adjacent benefit also, which is that you can essentially create your entire network using software, right, running on commodity hardware. Now that directly talks to the cost savings that you would get, and we're talking about a significant amount of cost savings, right? Rakuten has published reports where we go to around 30 to 50% of capex savings and almost a similar amount of opex savings because we adopted Open RAN. And like you mentioned, right, I mean, we have been the pioneer in this space, not just building Open RAN software, but also being the largest consumer of Open RAN and first and the largest consumer of Open RAN. So I think, just to kind of summarize, right, Open RAN, I think the way we need to look at it is the vendor diversity it brings that drives down cost, and the programmability that it brings that enables you to go and very quickly lay out your network, increase your cell sites, manage the life cycle, and all of those things, which again drive towards significant savings in OPEX. And of course, in the rest of our discussion today, we'll talk about how cloud native essentially plays a very integral part in enabling this for Open RAN.
Excellent. Adnan, I want to give you a chance at sort of answering this point of view, or providing your point of view too, since you're right down in the middle of this every day. Tell us a little bit about the benefits that you're seeing.
So we're kind of in the middle of it, but kind of at the foundation level of it. So we kind of work with a lot of companies, including Rakuten, Symphony, Mobile, etc. So, I mean, for me, I would say some of the main, I suppose, benefits of Open RAN is related to three vectors. It's an innovation enabler, and I say that because by essentially opening up what used to be one box with one set of software into, essentially multiple boxes, multiple software components with open interfaces, you are giving the ability of basically what's called best-in-class either software or hardware components to be brought into the system to kind of bring in whatever innovations they have. Of course, then that drives in the second one, which is ecosystem and supplier diversity, which I think is important. I mean, there's always been this effort in the industry. If you remember the days of CIPRI to eCIPRI, there was Upside. They were trying to bring up a technique and open interfaces to have separation of radio from the baseband. It had some success, but really within the Open RAN and the ORAN Alliance, they have now really done all this work to specify eCIPRI in a way that it can be separated radio from the DU. So that does give you a good supply diversity for the radio sides to the DU side. And we've seen this in the early days of Rakuten and actually other Open RAN networks today that have been launched, for example, Dish in the US, same thing we're seeing with Vodafone in the UK. And then the third thing I can think of here that I think is very important for operators is by going down the Open RAN principles and having the hardware-software disaggregation, that usually means you can have the two different vectors focused on the best that can be available in that ecosystem. So on the hardware side, you're getting the best platforms, you're getting the best silicon that has kind of been developed over time, independently really of the software use case. So you're just getting the best in class of process technology, GPP platforms that are every 18 months, 2 years coming up with new silicon that gives you new performance, new capabilities. And in parallel, you're making it easier for the software ecosystem to also develop their best-in-class software, taking advantage of all the capabilities within, say, for example, in our case, in the case of Intel, the CPUs. I mean, there's a good example, I think, of some of these benefits seen in the real world. If you can imagine in the classical networks, when you have a deployment of a certain cell sites and you've chosen a certain vendor, and that vendor typically has kind of a combination of the hardware and the software. Take the Dish example, I think the previous speaker mentioned. I mean, they launched actually with a certain hardware platform and they had a certain software partner for their initial deployment, but because of they following the Open RAN principles, they were able over time to add in another software partner to their suppliers list as well. So that kind of flexibility that they got by just essentially focusing on different software suppliers running on the same hardware is quite unique. You would not have seen this in the old days of, say, classic RAN or traditional RAN.
Excellent, excellent. So in the last conversation, we saw Pardeep give actually some really good sort of 4 pillars of kind of what cloud native is all about, what some of the advantages and sort of benefits around that. But I would love to be able to get your thoughts in terms of what are some of the general principles that we're trying to achieve here, right? With cloud native, obviously, if we're talking about is Open RAN going to be a conduit to cloud native, what is it about cloud native that sort of makes it advantageous? And I think that Partha, you were leaning into this in sort of your response there. So I'd like to give you the chance to respond. What do you think are some of these general principles, and maybe talk a little bit about those advantages?
So I will start by actually bringing it down to the basics first and then build it up from there. Because what I'm seeing, and it's kind of quite disappointing, is that the industry is totally confused about what cloud native is. And because interchangeably they use cloud and cloud native. When I say cloud, I'm talking about public cloud. Just to set it in perspective, right? You can be 100% cloud native running applications on your laptop. So no public cloud presence whatsoever, and you can be 100% cloud native. And you can be running 100% of your application in the cloud and not be cloud native at all, right? So there is no commonality between cloud and cloud native. This is something that I think the industry needs to first understand. It's a very, very poor choice of word, cloud native, because people usually gravitate towards public cloud. So what is the difference? I think this is a very important thing that people need to understand, right? Public cloud is a consumption model where compute and compute-related resources like memory can be deployed very quickly, elastically, and you're essentially charged based on consumption. Cloud native is completely unrelated to that. Cloud native is essentially a technique by which you package your application and all its dependencies and deploy it in a highly opinionated stack that enforces how availability is managed and how resiliency and scaling is managed and the life cycle is managed. That is cloud native, and that's where the principles of Kubernetes come in. And that is the reason why you can deploy 100% cloud native applications completely on your laptop, including your private data centers, without anything to do with public cloud. With that background out of the way, now the question is, what are the principles, right? So I think the fundamental principles of cloud native that enables, of course, Open RAN is number one, as I said, is packaging all your applications and its dependencies into a framework, if you will, right? That framework is called containers. And then as a result of that, when a vendor ships your application, whether it's Open RAN or any other network function, or even other non-network function-based workloads also, you don't really have to figure out how do you install the dependencies. Everything it comes packaged, right? So it essentially makes that a lot easier. The second thing is, the second fundamental principle here is how do you manage how do you deploy these applications? And we all know that, when you're laying out a network or you're bringing up new cell sites, it's extremely complicated, right? To bring up just these network functions. So what cloud native does, again, through a very opinionated stack, is that it enforces how an application's initialization parameters are passed to the application. It enforces how multiple components can come up, right, on one or different machines in what is called as microservices, and how they can coordinate to form a network service, right, in a very automated manner. That's the other fundamental principle. And the third thing is, okay, now that it is deployed, how do you manage the lifecycle of it? The fundamental thing about lifecycle management, number one, is managing availability in the event of hardware and software failures. Now, you want one singular mechanism and workflow by which you will manage the resilience of multiple applications, right? You don't want, let's say, Open RAN vendor doing some sites, doing their availability in one way, and a different Open RAN vendor managing your other sites, doing it in another way. You want consistency, right? That is what cloud native essentially enforces. Alongside that would be upgrade. Upgrade is actually very important. See, one of the benefits of Open RAN and software-based RAN is that just like enterprise applications can be updated very frequently because they are not really dependent on the underlying hardware, you can essentially do the same for network function, which means that you can drive innovation much faster. But in order to do that, you also want to make your upgrade very seamless. And we all know, right, upgrading network functions is a very painful exercise. Now, again, what Cloud Native does here is that through its opinionated stack, it enforces a common framework by which you can upgrade any application, right? In the non-traditional and non-open RAN type environment, people call it the blue-green kind of a upgrade pattern and stuff like that. Some of that is leverageable even for open RAN, but there are other mechanisms through which you can achieve the same, but you essentially make it seamless across your different type of network functions and vendors. So these are the fundamental principles of cloud native that enable bringing back to the original discussion I was saying, that you want to get diversity, but at the same time you want to have consistency so that your OPEX costs go down, because you are using the same sort of tooling and workflow for managing all your diverse vendor network functions.
Excellent. Yeah, well put. Well put. Ildiko, talk to us a little bit about sort of your thoughts and from your organization's perspective here around cloud native. What are some of the principles? Anything to add or anything you're going to respond to?
I kind of agree and disagree with what Partha was saying. For instance, to me, cloud native as a term, I usually like to disconnect that from the Cloud Native Computing Foundation and Kubernetes. I know that they are using the term extensively, but when it comes to what cloud native itself as a term means, I think that does have a lot to do with cloud. Because when it comes to cloud native, and I think the reason why we kind of need a term like that, and it's unfortunate that it got very overloaded, but based on the early experiences that I have, I used to work for Ericsson before I joined the Open Infra Foundation, and I was working on their cloud platform, and it was a hard journey. Not just for Ericsson, but the whole telecom industry, to move from the very specified full stack deployments and environments where everything was integrated with everything, and you got everything from one vendor, both the hardware as well as operating system that was tailored, the applications, everything was one monolithic stack. Now, moving from there into a cloud environment where you have a pool of resources that are kind of treated as one machine, and your application is running on whichever server you're not supposed to know, that is a huge mindset shift. And when it comes to the telecom ecosystem, I think one of the biggest challenges throughout this journey was, moving from the opinionated stack onto cloud, is how to handle that kind of flexibility and how to decouple from the hardware layer and the operating system layer, and how to sort of let that go, how to design the applications in a way that they are able to run on a pool of resources like it was one machine physically, even though it's not. So when it comes to cloud native, that really is about the design principles that go into how you design and develop your applications. Because if they expect to run on one specific hardware architecture that is specialized for someone's use case, then they will never be cloud native. You can put them into a container, you can try to run them and orchestrate them with Kubernetes, it's not going to work. And I think that really is what's behind cloud native, that you really need to understand what Partha was also saying, that what happens with high availability, what happens with, moving the applications around, what happens when your application actually starts to interact or depend on that underlying layers of hardware and software infrastructure. So that parts I do agree with. But when it comes to talking about things like packaging, things like Kubernetes, I don't think that is part of cloud native. They are used in connection with the term cloud native, but I think cloud native is really about the application's design principles. And when we are looking at 5G, we are looking at 6G, I think that the importance of these next generation networks is also that there is an ability to redesign applications, to design new ones, and not just move legacy components around. So I think that as the industry is moving forward, making sure that there is an opportunity and a way to design the applications so that they fit on top of infrastructure, and designing applications with the underlying technologies in mind, that is important. And technology, I mean the cloud itself, whether it's public cloud, private cloud, hybrid, doesn't matter really. It also doesn't matter what software is running on that cloud technically, because how certain things are handled should not really be that different if it is in fact a cloud platform. And
Very good. Very good. Okay.
I think I will stop there.
So I appreciate the actually very, very in-depth response. I actually do want to cover off on another sort of question here, actually, and maybe this goes to Adnan. So let's get really to the crux of this, right? The crux of this issue that we have on this panel is, how is it a conduit, right? So how does Open RAN sort of facilitate the migration to this cloud native model that Ilko has been talking about here? What is specifically that that Open RAN does that allows for that facilitation to happen? Adnan, you want to take a shot at that?
Yeah, sure. I mean, I was going to try and add a bit to what the previous two commentators said. So, I mean, actually, the fine thing is about the word cloud and cloud native and so on. I mean, there is some good examples as well. Some of the work we did with someone like AWS, and actually also with Google and Antos that was actually announced at MWC. I mean, they're typical cloud players. They had their specific, let's call them CAS environments, be it the EKSA for AWS or Antos for Google. And in those environments, they were trying to essentially host the RAN workloads as well. Like we worked with them, obviously, from a FlexRAN perspective. And the idea really was they were trying to bring, I would say, all the learnings of the cloud data center type of the world, the IT side of the world, into the telco world. And like for us, even going back years and years now, the way we looked at this, to make something cloud native, it was a bit of a journey. It was, step one used to always be virtualization. I think the first time we did the deployment with Rakuten Mobile was a virtualized environment, and over time became a containerized environment. But these are kind of the steps to get there. And of course, by getting there and the ability to partition your code to some extent microservices, but more into pods and containers, I think once you go into pods and containers, you're starting now to get into the flexibility of hosting these applications, on different, I would say, hardware kind of units, be it a server in location A or location B. But even as we know, even in the cloud world, like when you're trying to buy a hardware platform, like buy a certain time for that platform, you can at times define certain characteristics of that hardware. You can decide, is it like a big CPU in terms of capability or less capable CPU? You can decide graphics if you want to have it or not. So there is also a concept of, even in the cloud world, you have some knowledge or at least some assumptions of the kind of hardware you'd like to use to get the best performance. Now, having said all that, given that was kind of the principles and kind of the journey, in terms of the advantages and like how to get there, I was actually having this funny conversation with one of my engineering managers who we used to be both together at Mindspeed. I was thinking, we used to do all these SOCs long time ago, and we used to build the software for the SOCs, as I think I was mentioned, like a monolithic type of environment. So an embedded OS, closed hardware functions, and we developed the entire software. And I was putting a comparison table versus the way we're doing currently with FlexRAN. So FlexRAN is our name for our vRAN implementation that runs on our Xeon platforms. So that's kind of our, I would say, on the journey to cloud native vRAN, that's what we're doing with the FlexRAN. And there's a lot of very interesting benefits. But in fact, one funny example came up, which was when you start off, say, on an SoC and an embedded OS, and you're building the software for that, there's a very tight coupling when you're going from that software to that hardware block. Whereas when you're doing this from principles of, I would say, virtualization and a GPP platform, you start to touch on the benefits, I think, of a cloud native, which is now you're looking at the compute, the underlying compute, as a big resource block. And you can use more of it or less of it as you need. And of course, if your cloud native is in a centralized environment, it tends to be easier to imagine how you're going to be using these techniques, because you can decide if you have one too many servers, you're running the software for one too many cell sites. Now you can start to look at all these resources as a big pool. And this is where the whole idea of scaling the resources, scaling the capacities that you want to address becomes a very kind of advantageous to go with cloud native. But again, to get to cloud native with Open RAN, you had to have the ability to do the hardware software disaggregation. You had to have the mindset of developing your software to be ready to be hosted in a pod. Now, the level of microservices, I'm guessing people can debate that. Is it fully microservices or is it kind of somewhat microservices? But the ability to run it in a pod and then from the pod host it on different servers, I think, is one of the key foundations. And to me, like having seen the simplicity of developing that software, the simplicity how it gets up and running on a platform, I think that's kind of been a very good thing for the vRAN and the Open RAN kind of momentum. So it gives you those benefits versus, I would say, the legacy implementations of the RAN. In terms of the challenges, by the way, this is a small note. I mean, the challenges is all the operators, the comm service providers in the world, they've been there for 10, 20, 30 plus years. They all have the experiences of how to build a network. And by that, I mean is they know what it takes to build the infrastructure, the hardware, the antennas, the towers, etc. And they know how to deal with, supply chain, etc. when it comes to going from, say, traditional RAN vendors, like was mentioned there from Ericsson as an example. So that's a well-known process. It's been fine-tuned over time. And the reality is for like Open RAN and vRAN, etc., it's still new. I mean, yes, there's been a few major deployments with some major operators, but it's not a huge percentage yet of the global suppliers in terms of what's happening for all the comm service providers. So there's a learning process that has to happen. And I think that's probably the challenge that I would see right now, is that we're kind of in that learning process for let's call them the operations teams, to become more familiar with this technology, for it to become more widely adopted within a wider community of comm service providers.
Excellent. We have just a little bit of time left here. I want to have just sort of one more question before we maybe go to the Q&A section here. I think we only have time for one Q&A question, but in terms of sort of the use cases that you guys have seen, maybe on your particular networks or with some of your clients, what are some of the use cases that are sort of driving interest here for Open RAN networks? We heard CAPEX, we heard OPEX, we've heard some innovation stuff, but is there anything that sort of jumps out at you? Maybe a more specific kind of a use case that you've sort of been witness to? Let's maybe go with Partha on your network, maybe.
Yeah, I mean, certainly, I think, whether you all agree with it or not publicly, cost is one of the major motivations for most decisions within a telco operator when they're selecting their vendors or their architectures, right? But beyond that, I think from a practical experience, all I can say is that, again, I think the fundamental thing here is that you're doing stuff in software, right? On commodity hardware to the extent possible. Now, one of the ways you can, one of the innovations, or rather one of the use cases that emerges when you do it in that manner, is that you can collect a lot of historical data, right? What's happening in your network? Where are your most faults happening? Which vendors, which particular chipset is causing most problems? Where is your power draw most, right? And all that stuff. And when you're running a network in pure software over a long period of time, that data is very valuable to drive other use cases, right? Use cases centered around, can we determine a pattern through actually learning what's happening in the network and use that pattern towards essentially automating, certain aspects of managing a network. Automating could be essentially eliminating failures even before they happen. For example, right, you're suddenly seeing a load is increasing, and prior experience tells you that it's quite possible that that could result in an outage. So you might essentially want to scale your services so that you don't really crash. Those kind of things. The second one is power management, and everybody's talking about power being a very, very important resource that needs to be actually managed to drive down TCO. Again, all that is also now possible because you're essentially running a network on software using cloud native. So there is a standard way in which you can essentially collect all these probes, store it for historical reasons, and then mine that, create patterns, and then drive better power optimization. So I think a lot of interesting use cases are emerging. They are still, I would say, we are still in the initial stages where we can see the benefits of these use cases. But I'm very confident, based on our own experience, right, at Rakuten Mobile and the vendors and the operators that we sell Rakuten Symphony products to, there are some very interesting use cases that are coming up that will address this whole lowering TCO, improving agility for operators.
Excellent. With the time that we have left here, I'd like to just address one question. I'll take any volunteer who wants to address this one. Okay. This one is, as we bring more openness into our networks, how are vendors approaching security in their premises deployments? So a question about security. Does anybody want to take that question on very with the time that we've got left? Any one of our panelists? There you go, Ildiko. Let's talk about security, please.
Not fully from a vendor perspective, but I mentioned the community that I'm working with. It's called Starting Axe, and it is used as the platform layer component, software component in O-RAN networks already in production. And the nice thing about this and how openness is really being more and more present in Open RAN. Anyone can go and check out the project, work with the community on various things. And when it comes to the security aspect, the Starting Axe community is always putting a high priority on security, both in terms of features that increase the platform's security, as well as audit logging and being able to extract information about anything that happened to the system, all towards running CV scans and making sure that the platform itself on the code level is as secure as possible. And when it comes to open source communities, I know that there are kind of concerns that I'm hearing from people that, it's open source, it must not be secure. However, it's kind of almost the opposite end, because you have more eyes on the code, more people, more companies who are able to take the code, test it, and harden it to the level that they would like it to be. And I think that this is a really important aspect in terms of open source, that security is in the focus point for most open source communities that I've been working with on the software side. And I think that these communities are also great places for people to come and share both concerns as well as solutions, practices, next steps, and work together on implementation. There is a lot that people in these communities are learning from each other, and through that they are also making the code and platforms and tools and applications more secure.
Excellent. Well, that's very positive to hear about the work that's going on in the community in regards to security. Obviously, that's a big question that always sort of ends up out there, particularly in regards to the open source stuff. So, anyways, I would like to thank my panelists for the great job that you guys did in regards to a fairly complex issue. And helping to clarify Open RAN, helping to clarify what it means to get to cloud native, and And with that, I'd like to thank the audience as well. So back to our hosts.
Thanks so much, Viet. That was a really good panel. Up next, we have our closing keynote from Wind River. Over to you now, Warren.
Good afternoon, everyone. In thinking about Open RAN and adoption of cloud-native concepts among providers, as technologists, we tend to go straight to technologies and implementations, but I'd like to share some food for thought with you today. CSPs don't want containers. They want applications and services to run seamlessly across different environments. CSPs don't want cloud native. They want scalability, automation, and manageability for distributed environments. CSPs don't want Open RAN. They want the business opportunity that comes from interoperability and innovation. But to get the things I just mentioned CSPs really do want, environment agnostic applications and services, scalability, automation, manageability, and the business opportunities 5G and future G promise, they will need to implement containers, cloud native, and Open RAN. Implementing cloud native Open RAN requires a massive change to how networks have been deployed until recently. It requires new and different ways of thinking about your network and working with your solution providers. This is where Wind River comes in by providing cloud native infrastructure that supports CSP's desired business outcomes. Hi, I'm Warren Bayek, and I'm the VP of Technology at Wind River. We think Open RAN is at a tipping point, and over the next 10 minutes or so, I'm going to share 3 key issues our customers are facing in their virtual and Open RAN deployments and offer some examples of how we've helped to overcome them. Over the past few years, we've helped several of our customers make the transition to cloud native with a product called Wind River Studio, which includes a Kubernetes container-based platform, full stack analytics, and an automation orchestration solution we call Conductor. This Studio product was designed specifically to be cloud native from the beginning and is focused on solving the unique challenges of the CSP journey to software-based Open RAN. During that time, we've worked very closely with our customers to understand their goals, and together we've experienced issues getting in the way. There are several challenges we've seen customers face adopting cloud-native technologies, but I'm going to focus on these 3, which seem to be top of mind right now. Achieving parity with legacy systems is table stakes. The system has to be as good or better than current systems. Since telco networks are so geographically and distributed and can be massive, operators need to be able to operate at scale. And lowering TCO is on everyone's mind. Rising cost of energy has only made this even more important recently. We started our journey with Verizon a little over 3 years ago. And in a 2021 interview with Fierce Wireless, Bill Stone, Verizon VP of Technology Development and Planning, said, "I stand firmly on the side that we would not be deploying it if it wasn't as good or better than what we have in place today." He went on to say, "We held the vendor's feet to the fire like we always do, and it's absolutely performing every bit as well as the legacy custom-based approach." With 10,000 sites deployed as of May this year and a goal of deploying 20,000 by the end of 2025, something's working right at Verizon. Vodafone has officially kicked off the installation of Open RAN equipment for 2,500 sites across Wales and Southwest England. Over the past several years, Vodafone's been working with the industry to evolve how equipment is designed and made several proof of concept deployments to trial the technology. Each development stage was designed to test the technology in increasingly complex scenarios. After validating this in lab environments, Vodafone installed Open RAN in rural locations before beginning a multi-site deployment in Torquay and Exeter called the Golden Cluster. The Golden Cluster installation was a significant success. Cloud-native Open RAN outperformed traditional mass and call success rates, as well as download and upload speeds across multiple spectrum frequencies. Due to these successes, Vodafone will now begin installing Open RAN technology at scale starting in Devon on the path to that 2,500 site goal. With key performance indicators or KPIs demonstrating the performance of Open RAN exceeds that of legacy equipment in the majority of areas, Vodafone can complete this rollout without compromising customer experience. Additionally, and maybe more importantly, due to the embedded interoperability of Open RAN, Vodafone can explore how working with specialist companies can introduce novel ways of enhancing its customer experience. The services which will enable these enhancements are made possible due to cloud-native Open RAN concepts. So clearly, we've shown the industry can achieve parity or better with legacy systems in live deployments. Now let's look at operations at scale, which can only be achieved with massive amounts of automation. Hyperautomation is a critical element to achieve operations at scale, or even operations at all, frankly, as Open RAN is deployed. The coming together and integration of disparate solutions and vendors creates a new challenge and therefore a new opportunity, which can only be solved through automation. The systems are simply too complex and too distributed to rely on human intervention. Elisa and Wind River have deployed the first fully automated edge data center for commercial service, and Elisa was able to reduce staff hours up to 90% with this solution. The major outcomes could be grouped into 3 areas: time to prepare, time to deploy, and the quality of the process. In terms of time to prepare, the biggest savings came from parameter settings, followed by environment prep work. The team was able to execute hundreds of tests and scripts before going into the live network in the same amount of time it would typically take to manually run much fewer tests using the traditional model. In terms of time to deploy, the overall time measured in terms of staff hours for commissioning the Edge DC from preparation, parameter settings to complete installation and testing is reduced by 90% as compared to doing those same tasks manually. Furthermore, the overall deployment time is reduced by around 50% thanks to the automation of the current high-touch human processes. Finally, for quality of process, automation brings in additional benefits where multiple tasks can now be run in parallel with minimal probability of human errors, reducing time to service and enhancing network quality. The cloud-native integrated Wind River solution provides the fully automated processes required to achieve network scalability. This slide's a little busy, but it illustrates the level of automation and communication needed for a system to operate at scale post-deployment. With Studio, your cloud platform generates tons of data in the form of logs and events, which then gets processed by the analytics engine. Analytics determines whether there's a need to execute a policy, tying in ML, data science, external data, and creates a recommendation, such as increased CPU allocation, etc. From there, a trigger flows to Conductor, which can execute the policy in the cloud platform. Resulting data then flows back again to analytics, repeating the cycle to keep the system optimized over time and under different performance characteristics. Implementing this sort of self-monitoring, self-healing automation enables the network to be operated by fewer humans, thereby reducing error while also increasing KPIs. Now, lowering TCO is on everyone's mind. And of course, the rising cost of energy has made this even more significant recently. Earlier this year, we completed a POC with Deutsche Telekom to demonstrate some key capabilities and validate the innovation versus TCO savings of some of the product's features. I'm including this slide because it's an exercise we can do with other service providers who wish to see the technology in action. On the topic of TCO, most all of the features listed here impact TCO in some way, some way more obvious than others, but for this talk, I'm going to focus on 1 and 3, CPU utilization and power consumption savings. In terms of CPU utilization or hardware footprint, by providing a fully functional Kubernetes master in the all-in-one architecture, Wind River Studio platform can perform all the required functions, management, storage, workers, on a single server. Additionally, the platform is highly footprint optimized, consuming only 2 cores of previous generation Intel processors like Ice Lakes, and through a close collaboration with Intel, we've reduced that footprint to 1 core on the latest Sapphire Rapids technology. This provides maximum cores for the cloud-native RAN and MEC software to optimize the CSP's flexibility to provide services in their Open RAN deployments. This is a unique and key differentiator for the Wind River platform, being the only CAS provider requiring 1 or at most 2 physical cores. At a recent Orin Plug Fest, a group of vendors cooperated to show how an Open RAN solution could provide up to 20% power savings. This test used Keysight's ORAN energy saving solution, which includes containerized Open RAN DU and Open RAN CU, Open RAN Cloud Platform, and finally processors with telemetry and power management features and accelerators to demonstrate reduction in power consumption across this multi-vendor Open RAN system. The test reproduced traffic scenarios like peak commuting as well as after school hours and idle times when many are sleeping. This group was able to reduce the power consumption of the Open RAN infrastructure by 9% during high mobile traffic times and up to 20% during low mobile traffic scenarios. This is important not only today as a current cost savings measure, but also since a recent GSMA report found 62% of the telecom industry by revenue has committed to reducing emissions over the next decade. Only through these sorts of collaborative efforts can we reach the energy savings required for those goals. As mentioned, these are just a few of the examples of how Wind River is working within the ecosystem to lower TCO. On that topic, we published a report with Analysis Mason last year, and CSP respondents ranked reduced TCO as the highest driver for adopting Open RAN. Not surprising. However, when you look at the report from a little different angle, you see, yes, TCO is important, but the real driver for Open RAN is the ability to deploy new services faster, support new enterprise revenue, and support innovation and diversification. Cloud native is fundamental to opening the development and delivery of these new services, which brings me back to the business outcomes that CSPs really want, which include TCO, but also a host of other things. So there is no one element driving cloud native Open RAN. There are several. This is why we believe we are nearing the tipping point for Open RAN. To learn more about Wind River's telecommunication solutions, including the full list of features I mentioned, visit windriver.com/telecommunications. And if you're interested in scheduling a workshop with our experts, you can click Workshop with our experts on that page. Thank you for your time today.
Thank you, Warren. That was great. And of course, allow me to close by thanking Wind River, Intel, Mavenir, and Rakuten Symphony. So that actually brings us to the end of day 2. Just to remind you to look out for the post-event survey at the end of the show, and to make sure you join us back here tomorrow at 11 a.m. Eastern Time, as we'll continue with our next session, discussing the role of private networks in the wider O-RAN evolution. See you tomorrow.